Let's look at this question, and that is question part C. I guess it is very clear, and the question reads, find the value of x given that the matrix 2x minus 6, negative 1, x squared, and 2 is a singular matrix. Find the value of x given that the matrix 2x minus 6, then negative 1, x squared, 2 as elements of that matrix is a singular matrix. For your information, you need to first understand that a singular matrix has its determinant as 0. So a singular matrix has its determinant as 0. So what we are going to do is to just write down that matrix with its elements well written. So you have 2x minus 6, then you have x squared, then you have negative 1, then you have 2. That is our matrix, and we want to show that this matrix is a singular matrix by first getting the value of x. So what we are going to do is to get the determinant. So we have to pick the elements of the main diagonal. We get their product, and we actually also get a product of the elements of the secondary diagonal. When we get the difference, that difference must give us 0 because the determinant of a singular matrix is 0. So I'll begin. 2x minus 6, these are elements of the main diagonal. You see, their product is obtained. Then you say less, so that's the first part that you can be able to have, less negative 1 multiplied by x squared. Those are elements of the secondary diagonal. So 2x minus 6 multiplied by 2. Then negative 1 times x squared. The elements of the secondary diagonal or of the second diagonal. What do we do? 2 times 2x, that gives us 4x less 12. Okay. Then that will be minus into negative x squared. And I've told you the difference must be 0 because this is a singular matrix. So we shall have 4x minus 12, then plus x squared. Negative and negative will give us positive. So that answer must be 0. So we rearrange this element so that you can be able to have a quadratic equation. We shall have x squared, okay, plus 4x minus 12. We shall solve this quadratically for us to get the value of x. What then do we do? We shall use the factorization method. We have to actually get the sum and product from this quadratic equation. The sum is 4 and the product is negative 12. Two numbers, when you multiply, you get negative 12. When you add, you get 4. You'll obviously get 6 and negative 2. So that 6 times negative 2, you get negative 12. 6 plus negative 2, you get 4. So we shall have now later on x squared plus 6x minus 2x minus 12. So we shall have x into x plus 6 minus 2 into x plus 6. So that our final answer becomes x minus 2, then x plus 6. So we will equate this to 0. So that x minus 2 is equals to 0. So that x is equals to 2. Then x plus 6 is equals to 0. Then we shall actually say then x is equals to negative 6. So x is either 2 or x is negative 6. Those are your most possible answers that you can be able to have in as far as that matrix being a singular matrix is concerned. Okay, that is all about that question. So something else, I have seen another question here, and I want us to look at that question. and see what we can be able to get as our answer. Okay, we will begin. Shall start from here. We have said in the figure below, AB is a tangent to the circle center O and radius 12 centimeters. The area of the triangle AOB is 120 centimeters and OXB is a straight line. So look at this. They have told us in this figure below, AB is a tangent. A tangent is a line that touches a circle at a particular point on its circumference. So AB is a tangent touching this circle at this point. And we've been told AO is the radius of this circle, and this radius measures 12 centimeters. And you have been told OXB is a straight line. So obviously you should actually use this concept that whenever a tangent meets a radius at a particular point on the circumference of that circle, they will always form 90 degrees. Correct. So a tangent meets a radius or a diameter and they always form 90 degrees. So that makes this triangle AOB to be an important right angled triangle. So if it is a right angled triangle, then we can be able to get length XB. We can be able to get this length XB. But first, lest we do not know the way forward to this question, we are supposed to actually get first this length AB. How to get that length AB? Look at this procedure. The easiest way to actually do this question. The area of a triangle is equal to a half times base times height. The area of a triangle given in this case is, look at this, 120 centimeters squared. They have said the area of the triangle AOB is 120 centimeters squared. So we shall say 120 centimeters squared is equals to a half times base. The base of the triangle is actually the same as the radius. That is 12. And the height is AB. That we do not know. So that 120 is equals to 2 there, 1 2 there, 6. So we shall have 6AB. So we shall divide both sides by 6 to get AB. So that our AB or our height is 20 centimeters. Once we've gotten this part as 20 centimeters, it is easier for us to get the whole of this length. Because this is a right angle triangle. And if this is 12 and this is 20, we can use what we call the Pythagoras theorem to get that hypotenuse, because this is the longest side of this right angle triangle. So we are going to say a squared plus b squared is equals to c squared. Then we shall have now this as our a and this as our b and this as our c. So we shall say 20 squared plus 12 squared is equals to c squared. So we shall have 400 plus 144 is equivalent to c squared. Let me pick my calculator. So yeah, I guess you can be able to see. So we have 20 squared, that is 400, 12 squared, that is 144. So it will be 400 plus 144, that gives us 544. So the sum of these two can give us, so we shall have 544 is equivalent to c squared. We have to get the square root. So the square root of the answer, 23.32. That is the square root of 544. So we have 23.32 as our C from this end to this end. But they actually talked about XB. So let's see. They want us to get the length from this point to this point. But we've known that the whole of this, because this is A, this is B, and this is O. So the whole of OB is 23.32. But somewhere here we have X. So they want us to get XB, not OB. Of course, OB is 23.32, but what is XB? We have actually known that this is the radius. Any line moving from the circumference to the center of the circle must be a radius. So if this radius is 12, this is also 12. So we shall also put here 12 centimeters. Okay, so if that is 12 centimeters, and we've known that from this point to this end is 23.32, it is easier for us to get from here to here. What do? we just take 23.32 less 12. Yeah, so answer minus 12, so you get 11.32. 11.32. So your xb is 11.32 centimeters. That is your xb, 11.32 centimeters. So unless you have a question on that, you can be able to ask, but I guess you can be able to go to the next question. Next question that is here. Okay, I think it is clear. They have said the table below shows the number of defective bolts from 40 samples. Number of defective bolts in terms of x, 0, 1, 2, 3, 4, 5. Frequency, y, that is f, 286411. Calculate the standard deviation. And of course, you need to understand that standard deviation is the difference between the values of what you've been given in terms of that data from the mean position. So we will first have to get the mean before we can even get the standard deviation. So alternatively, be able to prepare a frequency distribution table here for this ungrouped data so that you can use it to get the standard deviation. But we need first to get the mean. So I can put here x, I can put here f. In a layman's language, that is a frequency distribution table. Our values of x are 0, 1, 2, 3, 4, 5. 0, 1, 2, 3, 4, and 5. The frequency, or the number of times each defective bolt occurs, will be as follows: 20, 8, 6, okay, 4, then 1, 1. Now we want to get the mean. How do you get the mean? So first you'll say mean is equals to EFX over EF. The summation of frequency times the values of x divided by the summation of frequency. So we will be able to do this. I can be able to put this line here, and I do this and this so that I can get EF, the summation of frequency. Of course, the sum of all these frequencies should give us the summation of frequency. We don't need to add these numbers. You've been told in the question, the table below shows the number of defective bolts from 40 samples. So that becomes the summation of your frequencies. So you'll actually write here 40. But again, if you say 20 plus 8 plus 6 plus 4 plus 1 plus 1, it must give you the same answer. Now let's get EFX. So we can come here and prepare another column, and we get FX. We'll say 0 times 20, that is 0. 1 times 8, that is 8. 2 times 6, that gives you 12. And 3 times 4, you'll get also 12. 4 times 1, that is 4. 5 times 1, that is 5. So we shall get EFX. We just get the summation of all those numbers. So we'll have 0 plus 8 plus 12 plus 12 plus 4 plus 5. That gives you 41. So EFX is 41. Yeah, EFX is 41. So let's get the mean. So we shall say mean now is equals to EFX 41 over EF 40. So that you say 41. So answer divided by 40. You get 1.025 as your answer, 1.025. So you'll have 1.025. That is our mean. So if that is done, then you can come here and be able to say now standard deviation, abbreviated as that, standard deviation is equivalent to the square root of, okay, I guess you can be able to get that, the square root of the summation of, you see, open brackets, x minus x bar squared divided by the summation of f. So I made a mistake of starting this working from this end. I need to actually create a column here that will have this and then squared. So I think I can just prepare it somewhere here. you'll be able to do what you call a correlation. Assuming this is a continuation of this, we can create a column of x minus mean here. It must make sense. Okay, so we can add an f here. So ef into x minus that. Yeah, I guess that makes sense. Okay, so we will come here. We have ef into x minus mean squared over ef. So let's get first this minus this. So we'll be taking this, the value of x, then we say less mean. And this is our x bar, our mean. Okay? So we shall be taking x, then that, x, then that, x, then that. So 0 minus 1.025. It gives you negative 1.025. We'll say 1 minus 1.025, you'll get negative 0.025. Then 2 minus 1.025, you'll get 1. Okay, let's see. So we have 1 minus 1.025, negative 0.025. Then 2 minus 1.025, it gives you 0.975. Okay, 0.975. Then 3, this 3, that is x. Our x is 3. Then our mean is this. So 3 minus 1.025 gives you, so 3 minus 1.025, 1.975. So 1.975. Then you go to 4 minus 1.025, 2.975. So 2.975. Then the last one, 5 minus 1.025, will give you 3.975. After you've gotten that, we can come here and be able to create another column. Another column where we are going to say f into x minus mean and squared. So we shall first be getting the difference between the value of x and the mean with square, then you multiply by the frequency. We are actually going to capture those values here. So let's start. Let's use the first example so that you can know what you're supposed to do. Okay, let me put it here. So you see, you're going to say this is x minus mean negative 1.025. We have to get that first, x minus mean squared. Let me write these two very well. Okay, like that. So it will be x minus mean squared. Once you've gotten that as the answer, you multiply by the frequency. So you'll come here and say, open brackets, negative 1.025 to 5 squared. That is it. Then you multiply by the frequency. And the frequency for the first part is 20. So you say times 20. It gives you 21.0125. So 21.0125. Okay. The next one will be, open brackets, 0.025. It's negative. 0.025 close bracket squared. Okay, and then multiply by the frequency 8. So it gives you 0.005. So 0.005. Next, we'll say 0.975 squared. Then multiply by frequency 6. Get 5.70375. 5.70375. Next is 1.975 squared. That is the answer. Then you multiply that by the frequency, which is 4. Gives 15.6025. So 15.6025. Then you come here and say 2 next. Okay, 0.975 squared. Then you multiply by the frequency, which is 1. It's the same thing, so it will be 8.850625. Okay, and the last one is so that is for this, this for this, this for this, this for this, and this for this. So you have the last one, 3.975. So 3.975 squared. Then of course multiply by the frequency, which is 1. You just remain with 15.800625. So you're going to get the summation of this. The summation of f into x minus x bar squared. You'll add all those numbers so that we can be able to get the answer. So you'll say 21.0125 plus 0.005 plus 5.70375 plus 15.6025 plus 8.850625 plus 15.800625 to give you 66.975. Okay, 6.975. So we'll come here and say standard deviation is equals to square root of the whole of this is this one here, 66.975 divided by EF, the summation of frequency, which is 40, this one here. So this one, so you'll say answer divided by 40, it gives you that. And once you've gotten that as the answer, you finally get the square root. So the square root of this answer, square root of this answer, so it is 1.2939, which is the same as 1.2940. So our standard deviation is equivalent to 1.2940. Thank you for your time. Thank you for your time. That's what you can be able to do in terms of getting the standard deviation of ungrouped data. The standard deviation of ungrouped data. The standard deviation of ungrouped data.